I've been teasing this for a while now, and it's finally here, my new custom loop build, this time in the form C1. I had become quite attached to the custom loop I did in the NZX TH1, as it left me surprised with its looks and performance, but it was time to take it apart and do something new. Since that initial video, I made a few small changes to the H1. I added the Aquacomputer Quadro for two purposes. First, for some cool looking RGB, and secondly, I taped this temperature probe to one of the hottest fittings in the loop in order to get approximate coolant temperature readings. I'll be of course reusing most of the parts from the H1 build, starting with the EK Special Edition 3080 water block. As you can see here, I'm also using an adapter that plugs into the Quadro for RGB control. I'll have a link in the description to all the parts I'm using. The water block itself got a bit gunky inside, but I didn't bother cleaning it this time as it has no effect on performance. It always amazes me just how heavy this thing is. It's an absolute unit of a water block. Next up, we have the Ryzen 9 5900X, and I'll be using the EK Quantum Velocity water block this time. The reasoning here is that this block has a low liquid flow restriction, and considering I'll be using a very slow pump, it makes sense to optimize as much as possible. I will be sharing some measurements later on in the video, and I think the results are quite interesting. One of the parts I'll be changing for this build is the motherboard. I'll be using the B5500 AORUS Pro from GIGABYTE. It's a great looking board with excellent VRM, an integrated I/O shield, and to top it off, PCIe 4.0 support. Instead of the included riser cable, which only has Gen 3 support, I'm using the low-key Gen 4 riser, which is probably the best 4.0 riser currently on the market, and it just so happens that it fits the T1 perfectly. For the cooling solution, I'm using a cookie cutter setup here with the XSPC TX240 ultra-thin radiator paired with two Noctua slim fans. This is potentially the Achilles heel of this build. I know some people like to use full-size fans and sand them down to fit, but personally I think that's taking it a step too far. Do note that special screws are needed to mount these fans to the radiator, and I'll have a link for those in the description. One other thing I wanted to throw in is this Aquacomputer flow sensor, which I'll be using for the flow rate measurements I mentioned earlier. And then we have the Aquacomputer Quadro, which will pretty much serve as the main hub for the two fans, the RGB for the water block, a coolant temperature sensor, as well as the flow sensor. The only thing I don't like about the Quadro is the software. It's pretty buggy, it's bloaty, and you only get updates for a limited time, after which you have to purchase a yearly license. This is in my opinion unacceptable, considering that the software itself is quite poorly made. Now, we reach my least confidence-inspiring part of the build, which is the DCLT pump from Alphacool. I don't have any particular reason to dislike it. It's quiet, and the one used in the H1 didn't fail me either. It's just not as confidence-inspiring as some of the other parts that I use. And probably even less confidence-inspiring is the pump top that it mounts to. The build quality on this thing looks absolutely atrocious. But then again, you don't really have a lot of options in a small build such as this one. At the end of the day, maybe I'm just being too harsh on it. It's not here to win any beauty contests. I just wish something of a similar size existed, but with much better build quality. So here we are at the final part of assembling the loop. The unsleeved custom cables make for a much cleaner and easier build, and I'll have exact sizes and details in the description. As for the loop itself, we have a run going from the GPU outlet up and over the power supply by using two 90-degree fittings and a few extenders. All that's left at this point is to mount the radiator and pump res assembly on top and make the final tube runs. The Quadro also fits satisfyingly at the bottom of the case and is actually secured with nuts and bolts. The loop is ready to be filled. Connecting from the res to the GPU inlet, we have an insanely short tube run, which goes in an almost straight line. It's very satisfying how this all fits together with zero clearance issues. I also wanted to have a run up from the CPU block to the pass-through port at the rear of the case. I've seen a lot of builds ignore this, but I find it's worth the extra work, as now you have an easily accessible fill port, and you don't even have to open the case. Alright, so as I promised, one of the things I was very curious about is just how well the small DCLT pump fares. Our flow rate sits at 75 liters per hour, with the pump running at 100%. The pump then is running as per the manufacturer's maximum flow rate rating, which happens to be exactly 75 liters per hour. This should clear up any doubts about how well this pump can perform in a custom loop of this size. Of course, this flow rate is rather slow, but it's what the pump is rated for. Now let's move on to some temps. As always, my test of choice is Cyberpunk 2077. I'm using an all-core overclock on the 5900X that is in effect a pretty aggressive undervolt, and the same goes for the RTX 3080, which is running my usual undervolt, which in turn cuts about 100 watts of power usage. Now, as it's summer and currently there's a heat wave going around, the temps are not ideal. With the two slim Noctua fans running at a rather loud 1600 RPM, we're getting a 48.2 degrees on the coolant. A simple removal of the top panel drops the coolant temp by a pretty significant 6 degrees. I did another test, and this time I used two full-sized Arctic P12 fans and no top panel, and this did not make a big difference in performance, but it was significantly quieter at the same RPMs. This to me suggests that the bottleneck is actually the top panel of the case, and not so much the use of the slim fans. Although with full-size fans, you can probably push air through much more successfully, especially if you have them sitting flush against the panel with no gap. One thing that is a little frustrating is that if the case were just a bit taller, there would actually be enough room to run full-size fans, and you wouldn't have to send them down to fit. That said, I found the build to be extremely enjoyable. It's easy to forget, but the T1 has just 9.5 liters of volume, and the density of performance here is absolutely crazy. I would say that building something like this is definitely not for everyone, but if you're prepared to do the research and take your time with it, it's also a very rewarding process. That's it for this one. Thank you all for making it to the end of this video. I plan on keeping the T1 build as is for a while, and I might even do a long-term review video at a later date. But in the meanwhile, keep an eye out for more videos on my channel, as I do have some very interesting stuff coming.